Hey, this is Don from Padlock Technologies again with a quick tip video. Got a question about DHCP snooping, and I will explain what it is, where you put it in the network, why you should do it, and you're probably going to see this in a lot of IBNS 2.0 configurations, but they don't really thoroughly explain what it is. So we're just going to straight focus on DHCP snooping, and then hopefully you guys will start implementing it in your network. So let's go to the blackboard here. I like to do my title, so let's go DHCP snooping. All right. So where are you going to put this in the network? This is going to go at the access layer. This will not go in a core distribution design or a three-tier design. It's always going to be at the access layer. It will not be at the distribution layer or core layer or collapse core layer. So basically what this is you're going to have this access switch down here. All right. And we'll just do access switch. And then obviously you're going to have your ports going to, distribution or core. So we're just going to say core dis. And then you'll have, let's say, in shared services somewhere, you'll have a DHCP server. So the point of DHCP snooping, it is going to, at the access layer, all the ports, we have ports, will be untrusted. These will be untrusted ports. And then your upstream port is going to be trusted. Now, what does that do? Well, what that prevents is a rogue DHCP server. Let's say someone plugs in a DHCP server over here. Now, it doesn't have to be technically like a Windows server or anything like that. It's just anything that can give out IP addresses. You plug it in, and then you have some users down here. All right. So you got users down here. So what ends up happening without DHCP snooping is DHCP is not a protocol that has some kind of intelligence to it. What happens is from the DHCP perspective is whoever answers it first gives out the IP address. So you can have a rogue DHCP server here, bad guy, right? And then once you plug in, they could potentially get a DHCP address from this rogue server. All right. Now, the default gateway could be this server, and then when people are sending traffic to the default gateway, somebody who is doing Wireshark and sniffing the packets. So what DHCP snooping does is, again, these ports become untrusted. The upstream port becomes trusted. Now, what does that do is it negates anybody being able to plug in a DHCP server in the network because it's plugged into an untrusted port. So it will say, "Hey, I don't trust anything on these ports from a DHCP perspective. DHCP is only allowed to go upstream. All right, it's only allowed to go upstream and get back to this DHCP server." Now, there's a couple things that you can do with DHCP snooping, and there's other technologies that go off of this. So one thing you can do is DAI, which is dynamic ARP inspection. Wouldn't really put this in the network because this is more of a problem than not, and you got to be very careful doing DAI. The other thing that you can do is this thing called IP source guard, which utilizes the DHCP snooping database. The other thing that I see a lot of people when they do DHCP snooping, they do not actually put this configuration in here, which is having a DHCP snooping database. Now, what is the point of this? I'm gonna just put DBase here. What is the point of the DHCP snooping database? Well, DHCP snooping, since it maps IP address, MAC addresses to ports that get plugged in, this is not something that is saved. So in the weird situation, you're not having any redundancy or anything like that, where you just have this one access switch and that switch reboots. Well, now it has to rebuild that table all over again. With the DHCP snooping database, it keeps a record, a text file of the IP address, MAC address to ports mappings that's currently on this switch. So now if it reboots, what will happen is it will come up, reload that DHCP snooping database from that text file, and things will work a lot faster. If you do not have the database in there, it will take a little bit of time, and not like it's not a crazy amount of time or astronomical amount of time, but it will take some time to rebuild that database and have everything up and running. Now, the one thing that you have to worry about is this thing called, and this is by default unless you turn it off, it's called option 82, which gives you a lot more detail in the DHCP snooping packet, stuff like that. Now you turn it on, and you can do one or two things. You can turn it completely off if you want, or on your SVIs up here at your distro or collapsed core design, you would put a command called IP DHCP relay information trusted. Now, when you do that, it will trust that information coming from the option 82 packet and forward it on. Right now, I like having the option 82 in there because it gives you a lot more detail when you look at the DHCP snooping database. If you turn it off, you get less detail, but it depends on who you're asking. And then obviously you got to make sure you have your IP helpers to forward that packet onto the DHCP server. But I also use this DHCP relay information trusted so that I don't have to turn off option 82 with DHCP snooping when I configure it. The other thing about DHCP snooping, it is configured per VLAN. So you have to do, usually people just do all the VLANs that they have configured, but you could technically go, I only want to do DHCP snooping on my VLAN 10, 20, 30, etc. You could do it that way. But most people just put it on all the VLANs that are going to have DHCP enabled. Now, if you don't have DHCP enabled on the SVI, you kind of don't need it, but most people I see in designs, they have DHCP for all their VLANs, other than like static stuff where they don't want to do DHCP. In that case, that VLAN you would just prune off of the DHCP snooping configurations. Now, again, the main purpose of this is to avoid having a rogue device give out DHCP, and that can happen. I've seen that happen. You can spin up a DHCP server on a laptop. You can spin up a DHCP, somebody could plug a rogue AP in there, one of those home APs that give out DHCP addresses, and I've seen that someone plug that in, bring down a whole side of a network because they were getting DHCP from that, and that led to nowhere. It's basically black hole in the traffic. So if you're not implementing this now, you probably should implement this, but I would roll it out, test it, lab it, make sure it's the way you want it, and then roll it out company-wide or corporate-wide. This is not something that you just, oh, we're just going to turn this on and just immediately turn it on. And the last thing I'll say, and the most important part that I'll say, is a lot of people, when they implement this, they bring down their network because of one thing, one crucial thing. They forget the trusted port. They forget to trust the uplink port. Trust uplink. If you do not do this, you will effectively stop DHCP from working for wherever VLAN you configure DHCP snooping on. So you will get a call saying the network is down, and technically it's not down. It's just DHCP is not allowed to go through the uplink back to the port that needs the actual address. And I've seen people take down networks because of that, or take down networks, I'm going to say quote unquote, because the network is technically still up and functioning. It's just the user network that's depending on that IP address to get it. They can't get an IP address, thus they can't get on a network because they have a 169.254 address, and that leads to nowhere. So that's a little bit about DHCP snooping. Hope this video was informative. If you got any more questions, put it in the comment or send me an email, and I will get you an answer. This is Don from Padlock Technologies. Thank you, and have a nice day.